system, which includes the Fourier system, signal analysis, and low pass filter. These are our group members. First of all, me, Jagan Raj, AE230079, my address number, and after that, Muhammad Sharif Firdaus, and Hassan Kamaluddin Hassan, and Osman Hamdan Adam Gamudi. This project uses Fourier series to design a low pass filter that allows low frequency signal to pass while blocking high frequency signals. MATLAB uses this to analyze the signal by using the Fourier series and Proteus to simulate the filter circuit and observe its performance as well. The methodology for this project is we use two different software, which is MATLAB to simulate the signals and Proteus to simulate the low pass filter circuit as well. For MATLAB, the Fourier series was applied to decompose the input signal into frequency components. The response of a low pass filter was then analyzed using MATLAB to verify attenuation of high frequencies. And for Proteus, we use it for the low pass filter circuit designed and simulated in Proteus. The output waveform was observed to confirm that only low frequency signal passed through the circuit. For the Fourier series signal analysis manual calculation, the fundamental frequency F0 is equals to 120 kHz, and the cutoff frequency is equals to F equals to 75 kHz, and the pulse of it is equals to 1 over 2 TO, and the period time is equals to 1 over F0, which we uses. And then we uses the derivative formula that was given for Fourier series coefficient. We use it, and then we were able to derive and able to come to the conclusion that x and t over t over sin c n here, which is equals to sin cx over equals to sin x over x, which is the simplest form of this derivation.
BE230020. For one, this project requests you to work with MATLAB. Use the code that you have writing in Prject task 1 and 2 and 3. I will show you. That is for this code for task 1. And now run. This is the result for task 1. And for task 2, this is code. And now run. And that is result. And sign use n equal 5, 10, 20. You can see that is result. Now for task 3, that is code. That is the code. Now run. That is the result. Two, do a Fourier series analyze for the signal given your group, and below the signal in time domain for 5 and 10 and 20. Analyze the signal both in time domain and frequency domain. Okay, that is the code for 2 for a series and F2. Okay, now run. And this result for 5. This for 10, you can see, and this is the 20.
A question for us. So for question 3, construct a low pass filter using MATLAB scale with frequency response characteristic as that given in figure 1, where FC equal cutoff frequency and gain F equal to log V out F over VNF. So the solution. This is our code in the MATLAB. As you can see, I'm going to make a run for the code. So this is our result, as you can see, for the board diagram. So I'm going to show of the filter both in time domain and frequency domain. So let's go back from the MATLAB. So this is our code for task 4. I'm going to make run for the code, and as you can see, this is our result of the task 4. Low pass filter frequency response.
For the manual qualification of circuit of low pass filter, the given frequency is 120 kilohertz and the cutoff frequency is equals to 750 kilohertz, and we assume the resistor value is 10 kilo ohms here, and we use the formula Fc equals to 1 over 2 pi Rc, in which we segregate the C, converted the formula to C equals to 1 over 2 pi RFO, and then we inputted the given value to get the value of capacitor value of 1.77 times 10 to the power of negative 12 F.
My name is Muhammad Sheikh. Then we will get the comparison between 10%, 20%, 50%, 70%, and 80%. So the between is around here. Here is 10%, and then here is 20%. Here is 30%, and here is 70%, and then 80%. Okay. That's all from me. Thank you.
To conclude this project, the Fourier series were used to analyze the and design a low-pass filter. The MATLAB helped to derive the sync shape, frequency response, and the response of the signal, showing low-pass behavior. And the Pultis helped to simulate the confirm the filter allows low frequency while blocking high ones, and were helpful to create a circuit as well, which was very helpful. And thank you so much for listening for this project. Hello and